Okay, so we need to do a minimal spanning tree, and we need to say how many edges with weight 2 will not be included. So let's just work out our minimal spanning tree and see what's left at the end. So we can start with this. There's a 1. And what's the lowest number that's connected along the whole length of that? Well, the whole length of that, there's another 1. We can connect to that. Again, looking along the whole length of that, we've got lots of 2's. So it doesn't actually matter how much we connect these things. There's a 2 there, and still looking along the whole length, we've got a whole bunch of 2's. So we can do a 2 here. And we're going to do a 2 here. We're still looking along the whole length, but already we've got a 2 that we don't need. Otherwise, we're going to make a face. And we've got a 2 here, and a 2 here. And we don't need a 2 there, but we've got to connect. We've got more than one choice on these things. We can make a 2 there. So we've already got 4 2's we don't need to connect. Let's have a look on this next part. So our next lowest number connected to the whole diagram, which doesn't make a face, is 3. And then we can do a 2 for that one. And, oh, we can do a 2, that 2. Doesn't matter which 2 you do. And so how many 2's did we not use? Well, 1, 2, 3, 4, 5. So I think the answer is 5, which is C. So the answer for question 6 is that. And so really what we're actually looking at is if you make a triangle, you got 2 and 2 and 2, well, you can only use 2 of them. And you can see there's actually a whole bunch of those triangles forming here. So you've got a triangle here, and a triangle here, a triangle here, and you've got a triangle there. But that's actually a slightly different case. It depends on which one you picked. But you can see why we're not picking those 2's, because as soon as you make a face, you can't have a minimal spanning tree. Okay, so we need to look at this idea of a simple connected graph. One vertex is odd and one is even. Which one of the following could be the number of vertices with an odd degree in this path? I wasn't exactly sure how to do this one, but I thought, okay, well, first of all, simple connected graph. A simple connected graph doesn't have any loops, and it doesn't have any double connections like this. Okay, so I just started drawing a diagram. And here's a vertex connected to another vertex. That's the simplest diagram I can think of. But if we look at this, this one's odd, but so is this one's odd. So we've got to add another thing, and you can't add it to the previous one. So we're going to add another vertex and connect it up to here, and that's looking pretty good to meet our criteria. We've got an odd and another odd, so we've got at least one odd and we've got one even, but we've only got 2 odd ones there, and 2 is not an option, so it can't be that one. And then I think, okay, where else can I add my vertex? So I could add a vertex here, but if every time I do that, I've converted one of my odds to an even. So this odd is now even, and so I'm in this situation. I only ever end up with two odds at the end. Oops, pressed the wrong button. So I don't want to just have an odd and an odd at the end and evens in the middle. So it's not going to be whatever my graph looks like. It's not going to be a straight line, sort of all the things. So I'm going to add another connection. It's not going to be a straight line. I'll do one out here. There you go. What have I got? I've got, in this situation, an odd, an odd, and an odd, because I've got 3 ends now. And oh, I've got 4 odds, actually, and one even there. All right, so 4 looks like a possibility. I'm going to put a little question mark next to it because I'm still not really sure about what's going on with my puzzle here. Now the funny thing is, it depends where you add things, does it or doesn't it? Because when you attach to an odd, you make it even. When you attach to an even, you make it odd, right? So if I had that same diagram like this, and instead I drew a line like that, then I would end up with 1, 2 odd and 2 even. So that's not really meeting my criteria because I need to have more than 2. So even in that diagram, I'd have to add another one to make another odd. But as soon as I add that odd, it changes the even to an odd, doesn't it? So that'll make this one odd, 2, 3, 4 odd, and then the other 2 would be even. So it's really looking like that 4 odd is what happens every time I'm adding to that. So it's not the most elegant solution. I've just been playing around with it, and if I was in the exam, I might, come back to this and play around and see if anything else comes up later. But I'd be reasonably happy enough to go, all right, the answer is B4. And believe it or not, that is actually the correct answer. You can play around with these graphs as much as you like, fill in the time if you've been quite efficient with your study and had lots of time left over, but you'll never be able to change that. Okay, so we've got a project here and we've got a precedence table. It looks like we're going to have to draw out a rough diagram of what's happening. So let's put our start here, and we can see that A and B both have an earliest start time of 0 and no predecessors. So we just go like, okay, we're going to put A going at the top here and B coming down here. Now we can look at C. Now C says it only has A is the immediate predecessor, so we can just go, okay, here's C. Let's check D. What can we do with D? D is just before B, so we can put D here. Let's look at E. E only has C in front of it, so we can put E there. F only has D, so we're just just extending this line out, F and D. We're getting towards the end, so G only has E, so I'm going to start bringing G down just because I know I'm nearing the end. G. Oh, and H is the last one left, this one here, and we've got to look at F and G, so I'm going to just like modify my diagram a little bit and take that line F up to G there, across to here. Here's activity H, and that will be our finish at the end there. Now, normally in these situations you have little the boxes that you put at each node. I'm going to do it in a different color just to help with everything. So here's the boxes. I do at each node here. It's going to get quite cramped, all this. There should be a box there as well. Box there, and a box there. All right, so we know that the earliest start time of everything is always going to be 0 in the left-hand box. Now, the earliest start time for C is 4. Now, the start of C is here, so the earliest start time is 4, which means the length of activity A is 4. We don't have to put these in, I'm just helping you out. You'll see later on with the problem. Now for D, the earliest start time is 12. So at the start of D, it is 12, therefore B takes a length of 12. E has an earliest start time of 15. So at the beginning of E, which this is the beginning of E, we've got 15. The difference between 15 and 4 is 11. So activity C takes 11 to complete. Activity F is a start time of 19. So put a little 19 in there. Difference between 12 and 19 for activity D means 7. G has an earliest start time of 27, so we can put a 27 in there. And the 27 and 15 difference between the two boxes that are connecting E, you get a difference of 12. Now it says also that H has an earliest start time of 36, so the beginning of H is 36. Okay. Now, it also tells us that C is not in the critical path, and the maximum, we want to work out the maximum delay of C, and we know that G takes 3 hours, so we can actually put our 3 hours in there for G is 3 hours. So if you think about this, if you've got, okay, to get some highlighting pens here, if we've got 27 here, and we've got 19 here, should actually add that this is thing that makes this one 17, because 19 plus 17 gives me the 36. If I look, I'm going to go in green because we're running out of space here. If we look, if you've got 36 here, that's the highest number coming in, and it can't be from the, it must be from the critical path, and C is not in the critical path. So it looks like the critical path is actually that path. And when I do my little green writing, so you've got 27 plus 3, that gives me a 30 coming in here. And so the it was the 19 plus the 17 gave us the 36. So we had these two numbers coming into this point, and we chose the biggest number because we're doing our forward pass. So we chose 36. But the difference between those two numbers is 30. We've got this 30 here in terrible writing, and we've got a 36 here. The difference between those is 6 hours. And that is the answer D. There's a difference of 6 hours. So just building up the diagram and realizing like what would be in the other competing lines. Quite a simple diagram in the end. And you got the answer 6 hours, which was D.